thank you all very much for sticking it out to the last panel of the day. I promise to at least not put you to sleep. When we started putting together the panels for the SDDC, we were a little confused at first about what VMware might be announcing at VMworld. And then I went to VMworld and I realized that applications are going to play a really huge role in the future of networking based on some of the things that I was hearing. So I decided to put together a panel to talk more about applications. And thankfully these gentlemen all agreed to sit here and let me throw questions at them. So what I want to do real quick is I want to take about 1 to 2 minutes for each of them to introduce themselves to you and to kind of give an overview of where they fall into the SDDC from their perspective. So Ivan, would you like to start?
Thank you. So I'm Ivan Pepelnjak, blogging at ipspace.net, and I'm usually the guy that's telling you that the emperor's wardrobe is empty. I also did a lot of application programming a while ago, and I'm still involved in that, including the application architecture, so thanks for inviting me.
I'm Najam Ahmad. I'm part of the Facebook network team, and essentially responsible for all production network infrastructure, everything that happens inside the data center and all the way to the end user. So the way to think about this is end user on their mobile phone or on a browser, how do they get to Facebook, a server on the Facebook network, and then back to the end user. Application is what Facebook is essentially, not the app itself, but Facebook itself is a fairly large application. So there's a lot of tight integration between the different components of the infrastructure that make Facebook happen. So software is really important for that perspective.
Okay, I'm Terry Slattery. I'm a consultant with Chesapeake Net Craftsman. Some people know me as being an early CCIE. I work with a bunch of customers on helping their networks get better and help them actually achieve stuff with their networks, actually run their businesses. So that's my perspective. And also done a fair amount in network management, so I bring that perspective of how do you make sure that the network is doing what it's supposed to.
Hi, I'm Dave Husak. I'm founder and CEO of Plexxi, which is a 2.5-year-old venture-funded startup that's delivering an SDN networking system that's driven by, if you heard some of my other earlier talks, driven by a network abstraction, a system, an application abstraction we call Affinity, and which we believe enables a lot of the software-defined data center features and value propositions that we've been hearing about today.
Hello, my name is David Cheperdak. I currently work for NEC, and I'm the lead architect of developing a OpenFlow-driven open SDDC ecosystem that includes both an open southbound API, more than 10 switch vendors, all working in interoperability, OpenFlow 1.0, 1.3, and an open northbound API, which is kind of building a whole suite of applications and services from security, DDoS, WAN optimization, load balancing, ADCs, and really building the full stack solution, layer 1 through layer 7.
And my name is Marco Di Benedetto. I'm the CTO and co-founder of Embrane. Embrane is focusing on layer 4.7 network services, and so in our vision, the application is the center. We call it application-centric networking. Application is at the center of all the networking infrastructure. So instead of working with network services that are shared across multiple applications, the objective, the goal for us is to create dedicated instances that can move together with the application, that can grow with the application, that can be migrated with the application, and they're belonging, they're an integral part of the application.
Very good. Thank you very much. So let's get started. So we all know that ensuring that the network is capable of supporting the needs of applications is important, but it looks like it's probably going to lead to a substantial increase in the amount of support costs and engineering time. Ivan, do you see these costs being mitigated through the use of some of the technologies in the software-defined data center, or not?
Well, it depends on how you structure things. So if you change your processes, if you do things better because you have deployed software-defined data center, then yes, of course, you will reduce the costs. If you pretend that you can do things the old way, using new tools, forget it. It will be just more expensive.
I agree. Anyone else have a perspective on this?
Sure. Really what we see from our open southbound API partners is OpenFlow in their infrastructure is a new driving force for marketing. It's a new roadmap for product innovation and also increasing market share. So we actually see no increase in cost. Sure, there's cost for increase in research and development, research and implementation, but really taking the old, even in some cases the old switch firmware, you can just update it with an OpenFlow API layer and get layer 2 forwarding capability. So what we really see is that this common open ecosystem of features exposed through an API gives new capabilities to applications, whether it be seeing what flow forwarding entries you have, being able to dynamically apply QoS, disaster recovery, 8-way ECMP, anything from even traffic steering and service chaining. I mean, these are every new capability added to the physical hardware layer results in a new capability in the application layer. So the more we can expose, the more the underlying physical architecture evolves, we get a much more powerful ecosystem.
I wanted to add something to Ivan's point on the operational savings, because it's true that by changing processes you can obtain operational savings, but by having better automation you can also improve, you can also get operational savings without having to change the processes right away. So it's the combination of these two factors, right? Being aware that your operational processes are problematic in a way, and so you have to make improvement to try to optimize the way that your IT team is delivering the infrastructure, but also the fact that the knowledge that you have new tools that enable you to take the processes that you have or the improved processes, automate them, and make sure with that the human intervention is reduced. Because I think one of the biggest costs on the operational side is the human error that can cause outages, that can cause mistakes, and so finding a way to minimize the human error is the reason why these business processes exist in the first place, and automation can mitigate that significantly.
Marco, sorry. Totally agree with you, but that's not the real cost that people are seeing. So I was talking with someone who, well, they are an outsourcing company. They claim they are a cloud provider, but they're really an outsourcing company. And it takes them like 4 weeks to provision a customer VM, because the networking team has to sign that off, the services team has to sign that off, the storage team has to create a LAN, and so on, and so on, and so on, and so on. Right. So if you shave 10 minutes off 4 weeks, you did nothing.
Right. Yeah, no, it's true. The issue is, on one side, yes, if the process is that way, and if the process includes sending an email to a person instead of sending a letter, stamped letter to a person, then you're not saving much. But if that process can be automated, the point of automating is not only reducing the amount of time that it takes for something to go from one person to the next person. It includes also the ability for these people to avoid the extra time in moving to the next step. Right. So moving from a step to the next step is important to be.
But this is not. I think what Ivan is asking about is it's the word automation. It's not automated execution of the same steps you'd otherwise do manually, right? It really is a problem of solving. It's sort of combinatorial complexity. It's death by 1,000 interdependencies. That it's going to be 10,000 interdependencies. Someone asked the question at the end of the last panel of, the bookshelves full of, provisioning, pick your favorite layer protocols, tools, applications, monitoring, right? We can't expect people to understand and solve for the combinatorial complexity of all the choices that they and their organization have made year after year after year of sort of in a model that demands, not only combinatorial complexity on a given device, but when you map that across an entire system where you're relying on the convergence of distributed protocols and coherent configuration that makes sense, it's a minefield, right? In fact, it's a field of mines with a little bit of empty space in it,
Now, and just to add to your point, I love it. When you have that combinatorial complexity, who will write the automation software to automate it?
Just on this point, I think I'll address both points in one go. Really, what NEC's controller is that combinatorial complexity at the core. And what we do is we separate the combinatorial complexity of automating your network, finding out the best paths for congestion, dealing with failover of link failure, all of the resiliency of the network that you would come to expect from a data center. That's completely separated from the business logic. Really what we provide is a logical abstraction that's decoupled from the physical layer. What we do is essentially take that model that you can expressively describe in a logical model through northbound API, through RESTful APIs, or by CLI. And what we do is we take that specification, aggregate all the tens of thousands of specifications in a virtual tenant network, and find out the best optimization for that through various core technologies and implement that into the switch fabric. So because you decouple it, you don't have to worry about, it's basically a sandbox that customers can use without having to worry about breaking anything or interfering with other tenants. And at the core, we take care of all the complexity of automation. Failover and say you unplug a switch, we automatically calculate new routes.
Now, as much as I admire your solution, you are addressing just one dimension of the combinatorial complexity.
Do you mind elaborating upon that, please?
Yeah, I mean, just throw in stateful firewalls, load balancers, storage, compute, you name it.
We're integrated with OpenStack, and we have partner with A10 for ADCs. I mean, we have a partner to fill every gap for every kind of service you would expect in SDDC. So, and within the VTN, every application, every service gets its own sandbox that it can operate inside. I mean, why are you looking at taking all of the complexity of all different solutions and trying to yourself at a orchestration layer, application layer, trying to figure out how to calculate the best optimization or orchestration? I mean, really, what you want to do is hide that complexity, just like the operating system model. No one programs the kernel for every single application. The kernel is the core that drives the hardware. And the user space, you can have drivers, you can have some API. You build your user space applications to use the kernel API. I mean, that's the scalable model, and it's in Linux today, So taking that same model and applying it to SDN, you have a fairly powerful solution.
But is the solution driven by sort of constraining choices, or changing the sort of the nature of the equation in terms of the number of combinatorial terms?
So the nature of the equation is purely by what kind of hardware you're using, right? I mean, as you add new switches, you get new capability. If you try to over-provision your network and say, I have one switch, but 10,000 tenants, of course that won't work. So I mean, yes, it's a little bit complex problem in terms of engineering your solution. There's many deployment and customer requirements you have to evaluate. If those constraints are well defined, you have a core validation technology that you can go in and say with a reasonable level of certainty, through some of our partners, you can even validate those solutions. And really you can say, this is what we're delivering to you, and we guarantee it to work within your constraints.
How many people do you think are needed to implement that, to manage that solution, to maintain that solution? Because I think in terms of business processes and automation, the conversation is around the number of people that are involved in that process, and not necessarily the automation. I mean, nobody is going to be trying to do static routes whenever you can have a routing protocol, and that goes well with all the other automations around the data path. But when it comes to business processes are more complex than just the data path, right? So what is the human element in that model?
So I think this is a multi-layered model. What I'm creating is not kind of just one nice layer. It's 4 or 5 layers. And we see is a separation of your services in the network, which our partners create. So our partners validate, test, and certify their own custom solutions and applications against their services. And within that domain, we essentially create a silo of control for each service. Then above those services, if you have a pool of services such as ADCs or DDoS mitigation or other kind of services in the network, how do you expose that to a pool of users? That really comes down to an orchestration problem of how you map and model or enforce SLA against a user, a set of users and their requirements to the set of services that are already automated. So I mean, I wouldn't expect a binary mapping between a user and one service. I would expect that a single service or multiple services could service many users. So really, that's part of what we're creating with our partner ecosystem. That's a problem that we're engineering over the next few months, is looking at what are the constraints and terms of the common API, and how do you orchestrate that and provide contention management even in the application space. And that's something a little bit different, is how do you manage contention between applications and demand for those applications.
All right, thank you.
I think it's a pretty lively conversation. I just had a question about hypervisor. And you're talking about outbound API and exposing a lot of hardware. Where does hypervisor fit into your model, especially when there's a hypervisor switch. That is sort of the center of gravity for VM provision in a way you could argue.
Good question.
Gentleman from Embrane, I'm so sorry I can't read your full name. You wrote in one paper that alluded to in one paper that hypervisor switch is good for certain functions, but it cannot scale very much. For load balance, or for firewall, or for things that are not necessarily in the data center all the time that they have to be. They are sort of location dependent. That hypervisor strategy do not function.
So what do you want to be addressed first? Okay, maybe this is fresher, so maybe I can address this question. So I don't necessarily recall the context of that statement. I mean, I think normally what I discuss is the role of virtual switching to host other types of functions that are beyond layer 2, and so there are functions that can be addressed within the hypervisor in general, regardless of whether it's located with the virtual switch or in some other kernel module or as an application co-located in the same hypervisor where the compute is. There are other functions that are naturally positioned in different locations. One example that I like to make is the example of defense at depth. When you have a defense at depth model, you're creating multiple layers of physical security because you want to be able to offer different attack points so that while different entry points get compromised, you have time to discover that a point has been compromised and react to that instead of having everything collapsed into a single enforcement point that is right in front of the VM, because in that model you cannot have defense of that unless you have separate elements that enforce your security. So I think the conversation is more about what type of enforcement model do you want to enable for security. Are you okay with just having logical representation of your DMZ and then collapsing that into a single physical enforcement point in front of the VM, or do you want to comply with stricter security rules that require something different? Similarly, for the load balancer, a load balancer is an entity that is required to be sitting in front of a number of VMs that are serving the role of backend server for the load balancer, and the expectation that all these VMs can be co-located on the same host is probably not realistic. And so, having the load balancer in a different location maybe can be optimal for some circumstances. The point is not whether or not a specific application is optimized with the load balancer with the compute VMs or the load balancer somewhere else. The point is you need to have enough control so that you can choose what is the best model and possibly automate the decision on what the best model is. And to do that, you need to have a proper provisioning function that enables you to create the different pieces in the right places.
So now looking quite after this, the reason I comment because good bit of conversation when using hardware features, the APIs. And what I was suggesting is the battle has shifted to hypervisor switching. That hardware features may not be the place where you want to play. The place is hypervisor virtual switch, and that is what you have to address. And I believe Embrane is pretty well aware of it. That's why it keeps defending its idea that hypervisor alone is not sufficient, that you do need to have hardware located in certain.
I don't know if you wanna...
Is there a question that you specifically wish? I know you had a question before. Do you mind restating it?
More on hypervisor and how you're...
Right. So in terms of, number one, why you would ever want hardware, right? An open data plane. Well, regardless of what networking solution you choose, whether it be overlay or some kind, I think there's another kind of technology it's not heard of too much, but you still need a common data plane to do forwarding. I mean, how are you going to connect hypervisors together?
Eventually the bits have to go from point A to point B, right?
Right. So, I mean, and when the bits get from point A to point B, how do you deal with the idea of, change within that physical forwarding plane? And that's really the question, right? It's saying, well, if I have a disaster, sure, my hypervisors are fine, but my switching hardware or my infrastructure, my legacy infrastructure has gone down. How do I react to that in a dynamic way? And really, that's where an open forwarding plane comes into play. Is you need that. You can run overlay, you can run legacy with OpenFlow if you want to, but at the core, you need an open data plane to drive that. In terms of hypervisor-based switching, well, I mean, maybe there could be an extension from OpenFlow extension to a hypervisor. Well, why not?
It exists. The vSwitch and the hypervisor is the vehicle for endpoint policy portability. It's the right point to attach that as resources are ported, scale, move. Attaching those properties and making them mobile with the vSwitch implementation is exactly the right answer, right? Yep. It also is the case that because it is a software environment, your ability to have a very rich set of packet manipulation, strategies and different kinds of pipeline architectures and such is sort of at your fingertips. It does not, however, as we were pointing out, it doesn't necessarily mean that what's in the hardware piece, the forwarding plane, is somehow moot, right? That it's a combination of those two factors that are ultimately going to achieve the level of fluidity, portability, and robustness that if we're going to ever solve the combinatorial crisis of building, configuring, maintaining, and operating these systems, we have to solve. And it has to be harness the best technologies at the points where they're most effective.
I think we could go on about this topic for the rest of the panel, but I wanted to get a couple more people involved. If we have a little bit of time at the end, I will be more than happy to take a couple of questions because Najam's starting to get a little antsy, so I'm going to pick on him.
I'm not.
Let's face it, like we heard with Jim Duffy's panel earlier, stakeholders have to pay for all of this, and they have a very different perspective. We can argue bits and bytes all day. They don't care. Things just work for them. And if it doesn't work, you get phone calls in the middle of the night. So, Najam, do you think that having a application-focused software-defined data center is something that the stakeholders can understand? It provides additional availability, provides additional speed to complete tasks and things like that. Because you have a very different perspective on this, being user-focused.
Yeah. So I'm somewhat feeling like the odd man out here in some sense, because I don't know what a hypervisor or hyperswitch or switch, those type of switches are, because we don't use any. It's all bare metal for us, because any sort of virtualization is a little bit overhead that we can't afford at our scale. So the problem space is actually very, very different. And I was just listening to the earlier part of the conversation as well. We actually love the complexity and diving into the nitty-gritty and at the bit level, rather than actually sort of trying to abstract away in some sense. So if you look at how we're building infrastructure that is supporting the application, it's really all about building an environment that one can provide the things like bandwidth that we need, but at the same time, I think the biggest thing for us is how do we detect how the production network or the infrastructure is behaving, and when something goes wrong, how do we quickly actually detect and fix it? So we tend not to try to build systems that are very, very whatever nomenclature you want to use, 5 nines, 6 nines, 7 nines. We don't worry about those things. We worry about if something goes wrong, will we detect it? And if we detect it, what would we do with it? And can we do it? Robots is the word that was used in the previous panel as well. So anything that's happening in the environment, we want to be able to detect it at different layers. And then if you have alarms, alerts, and different things that you're measuring at different part of the network or the entire infrastructure, how do you then correlate that into something that you can point to and say, this is what's actually happening in the environment, and then be able to react to it. So in our environment, we have lots of different applications running on the same infrastructure. We don't do a whole lot of compartmentalization or trying to protect one application from another application. It's all about what is the norm for this application at this time of the day, which could be transactions per second, transaction latency, things of that nature that we track very tightly. And all of that then is correlated into, well, this is not normal. So something's not normal. What are the things that are not normal? Can we correlate that, and can we get it to a point of saying, okay, this part of the system looks kind of funky. Let's take it offline. And that's our first reaction. It's just, let's take it offline. Move the traffic elsewhere. And then we'll go back and figure out how to deal with it. So that's the overall architecture that we try to build against. Failure is going to happen. We say a lot of things at Facebook that are kind of counterintuitive at times. We have posters that say move fast, break things. Or the one that I still sort of try to figure out how to implement in my own team is fail harder. What do you mean by fail harder on infrastructure? That's sort of hard to do. But the idea that human beings are going to make mistakes, if you try to fix the human beings, you're solving the wrong problem. Accept the human beings are going to make mistakes. Write software that will detect those mistakes and get past them. That's the flip model that we use.
Yeah, one of the things that I see in the network management space is a lot of the existing management tools don't have a clue about virtual networking. There's just no support. How many management tools are you aware of that don't understand MPLS? As an example, okay? Very few of them actually understand VLANs and can say, here's the VLAN, here is a VLAN, or here's the set of your VLANs, and here are all the switches that they encompass. So even that very rudimentary virtual networking is hard to come by on a lot of the management tools. So I think there's a lot of work to be done. And I'm hopeful that as part of this overall SDN approach, that network management kind of gets integrated with the network. And so we do start to have visibility into all of this.
Well, I want to pick up on sort of, I think, a key point that went past a little quickly in Najam's comment. But one of the real central values of an abstraction, an application abstraction for a software-defined networking or DC system, is that you're using that to measure you're using the application performance to assess the performance of the network in your example, right? That you're serving a feedback system against an error signal that is actually meaningful for your business, right? And that, I think where historically so many efforts in implementing QoS strategies and network automation and a whole bunch of other, like literally decades worth of attempts at doing that within the context of network engineering, it was sort of like, measuring the network against what the network is doing. And it was never really possible to definitively answer the question, is it behaving well? There might be some congestion here and a link down there, but is that bad? Or is that affecting anything? Should I do something about it? And by staring at, it was sort of naval contemplation, the network staring at the network to decide whether the network is okay. And what I think SDDC, SDN, SDS, SD all affords is a better perspective, a system level perspective that allows us to servo our systems against what the results that they are producing for the businesses and the entities that are using them as tools. And to the degree that we can that we can elevate our vision, elevate our perspective, we have a shot at solving the combinatorial problems and the human frailty problems that we confront in the way these systems are built and managed today.
I mean, it doesn't really matter if the network's up or down. Who cares? As long as the service is up.
If the service is up, yes.
I don't really care. Not possible to not have the network up and running while the application is still up. The other thing that I think I would just want to touch on it a little bit is traditionally the way we've solved these problems has been the problem, which is, to me, the S part is trying to address some of these, is where if you look at the network industry, it's been sort of a cult, it's been a separate group, it's in every company, it's the network guys or separate guys, and they're the only one who knows what the network is doing, they're the only ones who can troubleshoot it, they're the only one who can fix it. And that's been a divide that's been there forever. Not so much the case in the application space, and there's a ton of developers that are writing code against Linux boxes and all that, and they have visibility of the entire system. but the network? How many people have heard it must be the network? When people can't figure out what the problem is, then they point to the network. Well, the reason they do that is there's just this black box nature of the network that nobody really actually have a view of what's happening. And what we have the opportunity at this stage is to sort of remove those boundaries and actually make the network transparent. And much like any other compute system, why is it that we today still buy appliances as network boxes? Try and get in somebody, HP, Dell, whoever, to sell you a server that comes with some CPU that you don't know what that is. It comes with its own operating system. It slices and dices and all of that, but would you buy it if you have a server that you didn't know what the CPU was, or you didn't know what the operating system was? It was something.
But are the networking guys just sort of the last guys whose turn it is in the dunk tank, right? Did the server and application guys go through this 10, 15 years ago when...
It's the same model that broke in 80s for the servers, and that's what needs to break here as well, is that can we buy compute and then run software on it to be able to do lots of different things, including network. So if you look at how we do load balancing today, we don't buy appliances. We run them on our just general purpose machines. It's a distributed system, build a bunch of software, it runs on those compute boxes.
Just to address some of the points that was mentioned here, I can with reasonable certainty say that there is a need for hardware load balancers, partly because VMs don't cut it. And if we're looking at ISPs, carriers, or anyone who really cares about quality of service or an SLA. So just going through some of these points, really what we see through OpenFlow is I can see anything in any switch at any time, whether it be MPLS, QoS. I can abstract all of that information up into an application layer. So there is no limit in visibility to that forwarding plane. In fact, our controller automatically does preemptive calculation, and within the millisecond level can detect link failure, and within the millisecond level react to a link failure. So, when we're talking about an SLA, every minor failure, no matter how small it could impact the SLA. So, yes, it matters for some customers, a subset of customers, and the real question is, what market are you trying to target? So I just wanted to address that.
Now, if I might jump in, that's great that you give visibility into everything, but we do have to realize that what Facebook is doing, anyone could be doing that 20 years ago.
Of course.
They just are the only ones doing it. And there is no network management tool that can do it. Because the network management vendors still didn't get it. And why do you think that software-defined something will change that? It will still be the same programmers writing those tools and the same product managers writing the specs.
Sorry, I'm not quite following your logic here. Do you mind rephrasing the statement?
I think the point that I'm going to paraphrase your comment and see if I can make that point. The point that is being made is that the problems are solved by companies and vendors, and they have their own sort of reasons for doing that, and I understand the reasons why a company builds a product in certain ways, but a lot of time it becomes about control. I'll give you a very simple example. Pretty much every network uses NetFlow, right? Our network got too big for NetFlow. We were having lots of scaling problems, saying, how do we solve this problem? Of course, we could go back to the network vendors and have them build something and do a lot of work, buy a bunch of hardware, 12, 18 months later, we get something. But that's a proprietary solution in most cases and things of that nature. In our case, one developer sat down and thought about what we were going to do. We wrote a little shim for our kernel and deployed it on every machine that we have. And now we have what we call FB Flow. It's essentially a NetFlow record that we get from every server in the environment. So all we did was distributed the problem to the other CPUs that we had available. The point being that we don't have to solve it in the network domain. We can solve it where it makes sense to solve the problem.
And that's where I was going with the whole thing about SDN and incorporating network management in the whole envelope, or the whole thing that we're calling SDN here.
Correct. Which is why when I did the first day in the intro, I said from your so from your mobile handset to a server on Facebook and back, that entire set of technologies that are used are at play. And we should use the entire stack to solve the problem, not everything else solved in application, and then there's this network that is got a really, really hard boundary, and you got to get through the network team to get there, and I'm part of the network team, so.
So the question is, if the technology already exists in the network, why create something new?
So the point is not about creating new technology. I mean, I'm not going around saying go rewrite ISIS, because ISIS seems to work fairly well for what it does. It's not about recreating protocols as such. But if you look at all the problems we tend to solve is network is a set of distributed systems, and then we just keep reinventing new systems over and over again. BGP, OSPF, ISIS, MPLS, they're all distributed systems, and they all talk to each other, all nodes, and then every network person will solve it with another header on top. So we'll build some sort of a tunnel to do that. I've done that, been there, done that. So it's the using the right tool for the right reasons, and to sort of make my point, I'll give you another example. In one part of the network, we think BGP works really well. In another part of the network, we think BGP is just hampering us to no end. So in one part, which is closer to the server, I mean, we moved BGP all the way to the top of rack. We removed layer 2 completely from our environment. We moved BGP at the top of the rack because we think it works better than spanning tree type environments. Done. On the other edge, where we talk to the ISPs, there BGP doesn't give us enough control to manage our traffic efficiently at all. There we're building a controller-based system where we're sucking in the BGP routes. We're doing all sorts of business logic and business policies on it, and then we're pushing that back into the system saying, use this. Right? So it's the not reinventing BGP. BGP is still the protocol used to get routes from the ISPs. That's how ISPs talk to each other. But the decision-making process of which route to use is actually far more complicated than BGP allows today. So let's not take that. Let's put that in a controller, go solve it with software, figure out the best path, and push it back into it. Right?
And that's exactly what we do. That's really the whole point of OpenFlow is we're not changing switches, we're just adding an API to switches to make the whole thing a lot easier. And with this abstraction of all these switches into a single view point, a single physical switch model, now I can have a much more intelligence on how I do exactly that. I mean, OpenFlow is a open standard supported by ONF. I mean, Google has fully embraced it to achieve near 99.9% availability in their network fabric. So, I mean, it's there. It doesn't re-engineer anything. It just makes it easier. So, I mean, what you're describing to me is essentially OpenFlow. And OpenFlow itself works really well with both legacy. You can, terminate tunnels on OpenFlow if you want to, and you can just integrate it all together.
Najam he didn't really even, I don't think he even necessarily care what the protocol was that went and installed those flow table entries that actually. You were talking more about, using the operation of a legacy protocol, BGP in this case, as essentially as an input to a decision process, as opposed to a decision-making process all on its own. Exactly. And by being able to, fold that together with, business logic and other, things that are important to you, I think the OpenFlow piece was sort of, and then at the end, the flows get installed. I mean, that's the role that OpenFlow takes, but that is, a tiny part of what the solution he was articulating.
It's the brains of that high-order business logic. I mean, the only way you can implement there's many ways you could possibly implement it, but an efficient way to implement it is putting the business logic over fine-grained control, switch by switch, flow entry by flow entry, redirection by redirection, QoS policy by QoS policy, at any degree of granularity you want. I mean, that fine-grained control is how you implement any degree, any granularity of business policy. And so, what you're describing is sure. What you put in that domain where you need that fine-grained control is really what OpenFlow solves. You know, you can punt packets across using tunneling, but when you get to the point where it's mission critical, then you need a mission critical tool for solving that problem.
Well,
I mean, all I'll say is OpenFlow is just another tool. The concept is what's more important to me, and OpenFlow is exactly the same concept as well. I'm part of the ONF as such anyway, so I know OpenFlow really well. But again, OpenFlow is a tool to make that concept happen.
Right. Marco,
and you can do it several ways.
Okay, I mean, I think the conversation right now is about API and automation, and I think it's great to have better API to enable automation. I think the whole SDN movement started because people felt that the APIs that were available before were not good enough for all the jobs that were needed. And nowadays, instead, there's a plethora of different API models, and OpenFlow is one of them. Probably is the one that has been receiving most effort for standardization. But there's a lot of other different APIs, and so as long as the APIs that are available enable you to do the job that you need to do, then any API is good enough, and then you want the tools to be built on top of that.
Very good. Well, I've got at least one more question I want to ask, and we've got maybe 5 to 10 minutes, so we'll see if we can do this. So you guys seem to be dancing around one of my favorite topics that I've been thinking about recently with Najam's ideas about the network being a black box, and with Dave talking about all the information that the network can provide now that we're using tools like OpenFlow. Applications have historically been very needy things, and we have been told for years that the network needs to listen to my application and take care of everything. But now that our networks have been programmed to the point where they can provide so much more information in the other direction, is it time for applications to start listening to the network and providing configurability based on that information? And I know Terry has some very good thoughts on this because he attacked me in the hallway and said, I need to tell people this. So Terry, I want you to start out with that.
Okay, so when I was at Cisco Live, I'd be talking with a bunch of network engineers, and you go, oh, you know something about SDN? I don't get it. So I said, okay, here's a couple of examples. So the first one was, you have this network that's running, and you have a UC application, okay, unified communications. So you have voice, video, stuff like that running on the network. And today, you statically configure how much bandwidth is going to be used for that over certain paths. So it's all static configuration, and you have hard limits there, and you typically do policing when it exceeds those limits. What if the network could then tell, let's assume an SDN world now, okay, so let's switch from the static to the more dynamic world here. So now in the dynamic world, the network tells the UC controller, hey, I have more calls than you had initially estimated might be going over this particular path. What do you want to do about it? And they're actually talking with the application now, so the UC controller has several options. Can you provision me some more bandwidth? Another one might be, I went and asked the network controller, give me more bandwidth. The network controller said, there isn't any. And so now the UC controller goes, okay, now what are my options? Oh, let me go reduce the codecs in all the calls to a lower bandwidth codec. The calls can still go, and now I can have that other call that's coming in. So instead of all the calls having bad call performance, now you have them running at a lower bandwidth codec, or maybe enough of them so that this new call can participate. This is a way that the applications can actually talk to the network and vice versa and work together to solve problems. Now, yeah, there's a lot of administrative overhead in setting that up to make that go and defining all the mechanisms there. But that's the kind of idea, and people go, oh, that's interesting. And imagine doing the same thing with something like Oracle or any of your other big applications.
By the way, voice examples are awesome in my book.
Okay.
Just so you know. I'm an old voice guy. So does anybody else have any thoughts?
Sure.
Yeah.
I can just quickly, I know we don't have much time, I'll just quickly give 2 of probably about 20 different application, network-driven applications. If we look at Radware, for example, Radware is one of our partners. And they, in this particular use case, they provide DDoS mitigation, particularly within SYN flooding in this example. But what we can do by a network-aware application is we can analyze the network to detect a sequence or a signature that would identify the occurrence, maybe a spike in network performance, and also types of packets flowing through the network. Upon triggering that network sensor rule, we can then talk to our application. Our application can understand that an attack has occurred, and then we automatically steer traffic through a DDoS mitigation appliance that then cleans that traffic and re-injects it back on the network inline without interrupting any traffic flows, without any seamless exposure to any tenant or user or SLA. Another use case would be A10. We have our load balancers, both, or A10 load balancers, both physical appliances and also virtual. And the biggest idea is that, to deal with high level of traffic in a data center environment, I have to account for my highest peak, traffic within a year, within a day, within a month. And this often results in over-provisioning. And over-provisioning is, well, I have to run all of this live hot all the time, using more AC, using more hardware, using more power. Now, if I can dynamically increase the number of ADCs that I can spin up load balancers to address my requirements on demand, I can do that. So through an application, I can expect to see how much traffic I have from what sources, what subnets, what locations, and dynamically provision the network through our OpenStack plugin, spin up another ADC, and then redirect traffic to that ADC on demand within probably about a millisecond to second time frame. So, and this just gives you a few examples of the power of network control to real world problems that results to cache. And ultimately, the biggest kind of driving force in the industry today is how can I reduce cost, how can I increase value, and as a vendor, how can I increase profit?
Very good.
I have a brief comment. I kind of going back to the initial question that Tom had asked about is SDN going to actually improve the ROI any? It's going to reduce costs. I'm not sure it's going to reduce costs. The idea is to make the applications better, improve the business performance, make the networks more agile and more adaptive to the business requirements. Thus the example that I gave with voice.
Yep. And you guys use the word application differently, right?
Yeah.
You talk
means different things to different people. Right. So, but that's the idea, is to make the business actually perform better, and that's what you were saying with all the Facebook stuff. You're looking at the applications. How's the network supporting the applications? Because that's what generates the money. The network doesn't generate the money for the business. Sorry, network folks, get over it. That's it.
All right.
The performance of the application is very much measurable where
Yes.
the virtual machine resides. And if you can manage the virtual machine, if you can see the latency, if you can see how much CPU cycles it's using, if you can ping it, if you can, and those things are available today more so than ever.
And taking that data from the application or from the servers and feeding that back into the network is another way to do that coupling. Mm-hmm. And I think a lot of people are missing that in this whole SDN, and you get a lot of people wrapped up in that whole open flow thing and this protocol communications and defining flows and stuff like that. That's down in the weeds. That's not what it's about.
Making is that networking folks are still looking at application as an entity which is separate, which has to be measured. But what I'm saying is the game has changed. Mm-hmm. The promise measurement today is where the virtual machines are. That's the center of gravity. If your VM works well, your application will work fine.
And really that's where we look at this, is our OpenStack, our Red Hat partnership and our OpenStack integration. Is really, it's a full stack solution. We can't just silo SDN architecture and just say this is completely separate from compute. It's that hybrid reaction. A change in compute VM could impact the network and vice versa. So 100% understand, and that's something we're actively addressing.
Nils wants to say something really bad.
So the point he was making, that if you can just look at the bare metal or the VM, you know how the application works. What's your view on that? Because you're looking at it end to end. Aren't 80% of your problems?
Well, I was staying quiet because we don't have those vSwitches, so I don't know if the switches were doing well. But I don't believe that's the case, because that's just one view. And depends on your application. Obviously, if it's more of a self-contained application, it's not doing a lot of machine-to-machine or lots of east-west conversations, you may not have any issues, or it's not interacting with the user a lot, you may not see it. The thing to think about this is, say, I'll use our example is, we could have a end user sitting in Manila, Philippines, and the session is terminated in Prineville, Oregon, right? There's a long path. Doesn't matter what the VM is doing or not doing in that server where this ends up coming to, the session ends up coming to, it actually doesn't even come to a specific server machine, because there are lots of proxies in the middle to do all sorts of fun stuff. And then that request that a person in Manila made to www.facebook.com then gets distributed over hundreds of machines to collect what the user wants. So where is the problem? Where are you going to find it? It could be hundreds and hundreds and thousands of machines at a time. I put up a stat last time around in one of these conversations was, I took 1 byte HTTP request that came in, 1 kilobyte HTTP request that came in. It multiplied 930 times in our environment. So go figure where it went, how many machines it hit, and where the problem might be.
All right. Thank you, guys. We're about 5 minutes over, but I've been informed that the libations for the evening won't be ready for another 5 minutes. So, Stephen, is it all right if we take maybe one more question from the audience?
Yeah, sure.
Okay. This nice lady in the back had her hand up at the very first. You, ma'am, right there. You had a question earlier, and I'd like you to get a chance to ask it.
Actually asked my question. So, gentlemen were talking about. So first, I was to ask, would you find application end-to-end latency, or is the resource, the total resource used, storage an hour plus altogether, so whatever user would pay. One is the application latency that's more like computing. The other is the user would pay. That's actually different. So what I might find is applications and users. Second is from realities in data center, all the computing power and storage are separate segments. So when we do SDN, software-defined storage, network, software-defined server, they are all separate. So if your answer to my first question is end-to-end, how do you measure this? How do you really measure those total? And how do you improve the overall performance? Really address the applications. To only address network is not the total problem. That's two.
Anyone want to take a shot at that?
Sure.
I think OpenFlow might be the answer.
No, there's a use case for every technology, and it depends on what problem you're solving that you find the right tool to match the problem. And so OpenFlow solves one or more critical problems in a software-defined data center. But going to your point, I think the perspective is software-defined data center, or SDN, it might be misleading. I like to think of SDN as really what virtual machines and or orchestration did, or all these to cloud computing, which is really, creating a set of pooled compute resources. I think that SDN is going in the same direction, is creating a pool of network resources, so that you're no longer focused on the network if you don't want to. The focus is really on creating on the application. So when we say application focused, really you're focused on the application, not necessarily how that application gets its resources. Now, if what you want to do is analyze end-to-end performance, there are partners and technologies, even such things such as OAM, which can give you that degree of understanding of performance in the network. You can run your tests. You can provision some of the network and run your test to evaluate that. It could be a part of an automated service that you provide, or it could also be something that a user could evaluate. So, and just your second question, yeah?
Yeah, I'm sorry. So my point is, applications are there, but to really take application centric, like if you use some comprise, yes, it increase the networking utilization a lot.
Sure.
But if the distribution scheme is wrong, so basically you should not distribute the calculation so wide, which use the old network.
Right.
Which cost, although the network efficiency is up, the overall latency is down.
Right.
And meanwhile, you add lots of layers of visualization, which definitely still take extra time. So my point is, if you really take application centric, lots of new tools, new terms, actually even getting.
So if I can take this for a second.
This is the point I was trying to make earlier, if I might, quick second, is you can't just solve, if you're talking about application and applications at scale, you can't really solve it in one domain. You have to look at the entire stack. The way we end up doing it is that we think about modeling different applications into different types of models, where some are latency sensitive, some are actually just a lot of bandwidth, things of that nature. So you're trying to figure out what type of apps belong with each other, what mechanisms do you need to provide, but in the end you have to look at the entire thing. So I give you a practical example. We're constantly thinking about our storage because we have a ton of storage. And how do we do better in storage? And one of the things you have to do in storage is replicate it, have several copies of it. Well, several copies at our scale, where we're doing 7 petabytes of storage every month, it's hard to do. So how do you have not that many copies around? And the more copies you have and the further away they are, the more network bandwidth you have utilized, right? So right from the design phase of how we're designing storage, we look at that. And there's a pretty interesting math around how many copies do we keep. It's not an integer. Let me put it that way. And it's designed around network latency and reducing some of the network costs.
Yeah, one thing though, I mean, if I can interject here, one thing about, I think Facebook, Google are probably outliers in the context of regular application development cycles. And one aspect of the performance conversation for applications is whether or not you can measure performance while you're developing the application and solving the performance problem you might have even before you go to production. There are environments where the cycle from development to staging, testing, production are fluid. And so you can take that measurement and make the adjustments as you go wherever you want. And I think probably Facebook is one of those places where you can have that better control. But there are other places where instead there's a boundary that is very fixed between the development environment and the production environment. And if you had made a mistake and your application is not performing as well, you're not going to have the ability to measure that performance penalty to try to figure out what the problem is. So in my view, application-centric is looking at this other class of applications, or the other class of data centers, where you want to be able to replicate the environment that the developers have built, because what happens most often, from what I hear, is that the application works well in development, and then they put them in production, and all of a sudden the application is not working anymore, it's not performing, or it wasn't tested at scale in development because the resources were missing. So the goal of application-centric from our perspective on the Embrane side is to be able to build an environment for an application that is fully contained, that has all it's pretty much like an ecosystem, right? All the components are built and they're working, they're balanced, and everything seems to be okay. As you migrate that application from development to staging into production, you should be able to retain the same properties and not have to change those properties as you move from one place to the other. So application-centric in my mind means the ability to track those properties and to be able to make sure that those properties remain constant across whatever movement you need to make, which is something that is not typically possible today unless you use some of these new technologies, I think.
All right, I'm going to have to apologize right here because I blew my time by 15 minutes and I'm getting the hook. What I am going to do is I'm going to ask each of these gentlemen to hang around after the close of the symposium, because I know everyone out there has questions that you would love to get. Can you make it in 20 seconds?
The reason I was saying that hypervisor is the place for this performance to measure, it is because it has the visibility of both CPU, network, and storage. There is no other entity other than a base switch hypervisor management fleet that can see into it and tell you what's going on. Thank you.
All right. We're going to end it here so that we can close this out. But like I said, I want to thank each one of these gentlemen for participating in this panel. I think we had a little bit of discussion. I don't know. What do you guys think? And thank you all for coming.